Thank you, everyone. Good afternoon. We are very happy to have the panel discussion today, talk about how intelligent machine can happen in the real world. And we know that we talk about AI many times today, especially physical AI. And so this panel discussion, we are discussing that how AI is no longer confined in the car or software. It happened to the real world, to machine. So I'm very happy, I'm very delighted to have two distinguished guests, Ludo from NVIDIA and Dr. Iwamura from Omron Corporation. Thank you for your coming. Yeah. So the next 30 minutes, we are going to share that how, from NVIDIA point of view, from the technology, like AI as accelerator and the software, and Omron Corporation from the OT side, how can they implement that all the AI technology together as an equal partnership on the OT environment. So start from the big picture. People think about something fundamentally changed over the past 18 months for AI. AI changed a lot. So for Ludo, one question for you is that how is the customer now with NVIDIA platform that they are not able to do what you can provide from NVIDIA platform, what they can do that was not able like 12 or 18 months ago. And the second is that what is the visible change you are seeing in the past month?
Well, firstly, I'd like to profoundly thank Advantech for inviting NVIDIA. We are humbled and excited to continue to grow our valuable relationship with you while helping accelerate vital partners such as Omron. Enterprises can now close the loop between digital twins and real-world operations. They can simulate environments, generate accurate synthetic data, train models while deploying them in production within a continuous CI/CD loop. We see the most visible change is moving from standalone computer vision deployments to full operational AI systems that monitor, optimize, and act in real time across an entire workflow. Another major advancement, NVIDIA is deploying autonomous, self-evolving AI agent in production environments with enterprises-grade security. That's something that wasn't possible 12 to 18 months ago. NVIDIA's NemoClaw framework now provides the governance stack, moving AI agents beyond prototypes, which includes immutable logs, role-based access controls, combined with fleet orchestration. Customers can now deploy multi-agent systems by simply defining skills instead of building complex systems from the ground up. Skills are reusable capabilities. Examples include analyzing data, generating reports, or taking actions. This can now be easily shared across multiple agents.
Right, thank you, Ludo. So you know that when we talk about that time, we talk about that month and year, about AI evolution as something like the speed of the light. So we hear so many technology from NVIDIA. But down to the earth is that how do they implement in OT? So Dr. Iwamura, that from intelligent machine and factory operation, what have you seen and the change in the past month?
Next slide. Yeah, so the left side, generative AI adoption, I think it was emphasized in these sessions. So everybody knows between 2022 and now there's a big difference. And before 2002, many people feeling, when I ask to the customer, they say, how to use the AI? What is AI? Especially in the manufacturing, as you can see in the right side, in the IT world or knowledge management, they are using many AIs, but in the reality, in the factory floor, only 10% of the adaptation is happening in the last year. That is a reason, because the IT world, the information technology, there are so many data on the web, but in the operation data, there's many secrets, and it is impossible to run in the AI. And also, the meaning of the data is not inherited from the data to the IT world. That is a problem. Yeah. So between the 2022 and now the changes, previously, they are trying to AI as a strategic option, but now when we visit the customer, they always say, bring us the AI to the factory floor. That is the biggest change.
Right, so not only that we were talking about today, even from Omron, from OT side, from intelligent machine, and from factory, they are also asked by their customer, how can Omron or other that OT player that they can embed the AI to help our efficiency? So from a Advantech perspective, even though today we talk about intelligent machine and factory floor, but from working with our eco-partner together with software ISV or so many respectable technology leaders, we actually seeing AI is bring into the many industry. Of course, today we focus on factory. But again, I have to say, OT integration still remain a big challenge for everyone. Because that is not just that you need an edge platform, you need a lot of good quality data. But what Advantech doing now is that in order to minimize the gap and help our customer integrate the AI into a scalable edge AI platform, and we will partnership with NVIDIA to develop a different platform, not just on the AI accelerator, and with the domain we have, we integrate lots of I/O and field bus and connectivity to help our customer, no matter use on intelligent machine or on other application level. So next, I'm going to the bigger question is that, how do we do implementation? So Ludo, from the implementation, why I know NVIDIA have a lot of good technology, and also that what are the customer benefit from that? Also on the Omniverse, what are you seeing that what can help them, like they are not able to do before, but with the Omniverse and digital twin, help them to implement physical AI in the intelligent machine?
Well, synthetic data shifts industrial AI from a limited data scarce process to one of massive data availability. Instead of relying on very expensive and slow real-world data collection, customers can quickly generate huge amounts of perfectly labeled data while also simulating rare edge case scenarios. This enables faster training cycles, better model performance, and scalable deployment across complex environments that were previously impossible to support in the past. NVIDIA is now optimizing the entire physical AI stack for agents by making our libraries, models, and framework agent-ready. This includes our Omniverse libraries for simulation and digital twin, Cosmos World Foundation models for physical world reasoning and synthetic data generation, Isaac for robot simulation and robot learning, Metropolis for vision AI, Alpamayo for autonomous driving, and of course the Jetson platform for edge AI development.
Right. I would say that next to AI, the big buzzword is actually data. So simulation, synthetic data is really accelerate a lot of physical AI into OT world. So back to the OT side, so Dr. Iramura is that I know Omron have generate a huge amount of quality data from X-ray and from our AI machine. How does AI use those data in the factory floor?
Yeah, first of all, we have selling the AXI. It's X-ray, 3D X-ray inspection machine, and the AOI is optical inspection machines. And the AOI and the XI is we are trying to achieve the very difficult problems. Yeah, today I'd like to explain about the example of the HBM, high bandwidth memory. HBM is made of the DRAM, and it overlaid the several layers. And each layer has a through hole. It's called the TSB or TGB, through silicon beer or through glass beer. Yeah, this, as you can see in the picture, the size of the beer is very small. So when we use this AXI, even in expert, it's really difficult to judge this is a fail or true. So, and also, if you see the AOI, the component placement difference can judge. That also, if the size of the circuit boards make it smaller, it is really difficult to judge. To overcome this, can you go to the next slide? I was collaborated with the NVIDIA's Cosmos team. Yeah, and this is the first time we achieved in the we achieved this in the first time in the world, and today is the first time show in the public also. Yeah. To achieve the reasoning, this XI data, it requires to the annotation of the circuit board. As you can see, on the solder, there's a PCB and there's a solder, and as you can see in the color, why I'm putting a color is HBM in the real production line has a warpage problem. Because of the coefficient of the thermal expansion difference between the silicon and the copper, the difference is a 6-time difference. So when we add the heat onto the silicon tip and cool it down, the size of the width is different. So it will happen in the warpage in the circuit board. But the difference is very, very tiny. So if we use a BLM into that, it is impossible to understand using the BLM. It has to treat as a color, and also it has to treat with a 3D. That is the key point to overcome this problem. To overcome this problem, I introduced the multiple LMM and also the BLM, and also using the 3D annotation to that. So I'm using these kind of multiple collaboration of AI agents. Now I could achieve the reasoning of this problem. Like this problem, there's a warpage on the circuit board. As you can see, it can make the reasoning. And after that, you can ask the questions. And also, it can refocusing onto the problem point also. Yeah, that is the difficulty. The important point is how to add the meaning of the physical data to the AI. That's the point of this. Yeah.
So is that remarkable example from Omron is that this is exactly how use AI into the AOI XI machine. So actually, before the panel discussion, I had the chat with Dr. Iramura-san that can I say that because you say it's the world first. So and you haven't published it on the Omron PR yet. Maybe we can say today is that journey on VLM. Everyone know about VLM, video language model, and journey is for 2D. But Omron is world first to use VLM with a mix of AOI and XI. So with that, it's really like, it's not like using 2D because right now we know all the optical expression is 3D. So combined with VLM. And most important is that that's happening at the edge, which means that anything happening at the edge is related to the Advantech, right? Yeah. So, yeah. So I'm going to circle back to that the 3-computer framework from NVIDIA. Of course, everything landing is at the edge, but before at the edge, we need to do the simulation, we need to do the training, and with the Omniverse, with the digital twin. So with 3-computer framework, I think it's very important is that not just only robotics, even for machine simulation, you can do a lot of simulation, edge computer or server, Advantech server, Advantech workstation to running at that before we implement into the field. And this become the close continual workflow. And those that is not an isolated system. It's more like from sim to real or real to sim, and how can we learn and improve? So the next question, again, I have the 4 questions for each of them. So the third question will be that after implementation, I'm sure we faced some of the challenges in the past. So Dr. Iramura-san, can you share with us what are the difficulty that you face when you do the implementation? Especially we want to implement across different machine and different factory.
So there's a 3 steps to achieve that. First is, as I mentioned, assigning the physical data to the meaning. That was a so difficult thing because one solder to detect that, it has to set to the like a few hundred of the parameter. Yeah, and when you go to the manufacturing and the real process, when the failure will happen, yeah, because when we set to the failure, normally we have a margin, means a positive failure, and after that, when we fail the production line, it goes to the professional, and the professional will judge it is fail or not. Yeah, but when we that, the circuit, AI circuit was very expensive. So it means you have to judge very carefully. Even one failure is quite expensive. So that is the first step. And the next step is the IT-OT integration. This is, I mentioned that I assigned the meaning to the OT physical data. The next step is connect to the IT. So I collaborated with the Cosmos. It can make the reasoning, and means that it can read a human. That is the second step. And the third step is the human readiness. Even make the reasoning. If there's an operator or designer, their expert knowledge is different, means it has to be set as each person. And also it has to ready for like a designer case that has to be reason more detail. If it's an operator, it has to judge the failure, what to do. That is the most important things for the customer. So after finish these kind of 3 steps, now it can adapt AI to the real operation world. Yeah.
Right. Thank you for sharing. Indeed, it's not that AI is not just overnight, that after the data training, simulation, and you can do inference immediately, especially even though we implement AI, still some of the people that we need to over there on the factory floor. And the same question to Ludo is that what do you see from the platform perspective? What are the challenges?
Look, the biggest friction points is integration into existing systems and processes. Industrial environments often have fragmented and proprietary data sources, legacy infrastructure, and established inflexible workflows that have been difficult to address. There are also gaps between simulated environments and real-world variability, as well as the need to align AI systems with human operators and physical processes. The challenge is making AI fit naturally into production, not just proving that it works.
I see. Okay. So again, we have different role, right? From the OT, from the platform, also from the AI technology. Advantech provide a scalable AI platform. And what do we see from our view of the challenge is? This is complicated. I might explain that later. So we see is that from different applications, they will connect to different machine, and they will connect to different sensor, and then they may have different requirement for real-time latency. So by doing that, it's difficult to do. When you want to do AI project, it's very difficult. You do everything from the scratch by yourself. So within Advantech, we are providing the concept we call AI Foundry concept. This is provide 7 core modules. With these 7 core modules, instead of building everything by yourself from the scratch, we hope that we can provide you that standardized building block on the robotics or on heavy machinery, that if you need functional safety, then we have the module for functional safety. If you need the remote measurement, and we have the remote measurement remote measurement module. Last but not least is that all the AI need to connect it to sensing. And we are partnership with that our sensing partner, and to get every integration ready. So with the concept of AI Foundry, with the 7 core module we define, we are hoping to provide you the standard building block that we are working with the global eco partnership on the software partnership, also on the sensing partnership together with NVIDIA. So even though there's a challenge over there, there's a difficulty, and applications are fragmented. This is what we want to provide the building block. To summarize the panel discussion, the last one question wrong, it will be that, what is the future? It's very important, what is the future? Because AI is evolving so quickly. So question to Ludo is that, how do you think the factory in the year of 2030?
Well, I think it's a great question, but we don't see an environment of just simply managing individual robots. Instead, we anticipate singular, giant, self-operating robotic systems, coordinating fleets of humanoids, AMRs, and vision-based agents. This means manufacturing, warehousing, and distribution act as one system. NVIDIA's Physical AI Data Factory blueprint transforms this from concept to a standard practice by converting compute into physics-grounded synthetic training data at scale, cutting robot training iteration cycles from weeks to days. Our mega Omniverse blueprint means every future factory will be born in simulation first. Designed, tested, and optimized in a physically accurate digital twin before physical deployment, with robot fleets and AI agents validated in virtual environments first. This will significantly reduce TCO and ultimately drive meaningful ROIs.
Right, thank you. I mean, this is a slide also from people sharing about that for the future of factory. Not just only like AI factory brain, also with lots of the blueprint will be there with a lot of agentic AI. Thank you. So Dr. Iwamura, so what do you think from OT perspective, like what will be the factory floor look like, let's say in year 2030 or even in near age? Yeah.
So our company is really focusing on the, go to next, yes. Focusing on the equipment. Yeah. Our target is edge and the equipment. That is focusing on the point. And what is the important point is now equipment means if it's an inspection, just say false or true. But in the near future, it can ask to the equipment and it will change to the intelligent infrastructure and it can tell the reasoning why it happened. And the point is 4 dimension. Now it can take care of 3 dimensions, but I'm thinking it has to be extended to the 4 dimension with the entire engineering chain. When you design the inspection, it has to collect the data and add the meaning. And even in the go to the operation phase, it also needs to add in the meaning with a different aspect, and it has to be adapted to the human readiness. That is the important thing. And when we reach these kind of things, we call the Gemba DX. Gemba is a factory floor digital transformation. That is we are trying to achieve in the future.
Right.
Yeah.
Okay, from 3 to 4 dimension, I think it's another jump lead on that is very amazing. So from a Advantech point of view, I think it's a great ending because we, again, that 3 come together must be for some reason, you know, that we talk about AI factory brain. That from Deepu, from Miller, also I think early this morning, even though you did not join Jensen's keynote, you can watch the video, we talk about that. I think the future of physical AI is AI factory brain because everything will implement it in the factory. With AI factory brain, from Advantech point of view, we partnership with NVIDIA together with the NeMo Cloud, and of course with our WISE software. We develop a lot of agents. We only put some of them over there on the agent, and AI agent help Advantech factory, no matter on the automatic flow or also on the workflow or even on the SOP wise. And the other side, from Omron side in the future is that because you are the only one so far, the world first. We don't know who is the second, that you can have that use VRM for the mix of AOI, XI for the 3D inspection. That's very important. So which means that in the future of the factory, we will embed Advantech AI factory brand and together with NVIDIA technology, NeMo Cloud, and also the blueprint, and with the AI agent, and with Omron machine. So we expect that year 2030 is not 3-dimension inspection, it's 4-dimension. So to summarize, to closing our panel, the physical AI for the future, of course, everything is possible. But down to the factory floor, I think we need to make sure the AI factory brand is implemented, not only in Advantech, also around the world. And if I'm looking for the partner, I think Advantech factory will be the one together with Miller support, KC support. I think not next year, I think very soon, within few months, welcome everyone to visit Advantech factory to see how we implement AI factory brand and together with NVIDIA technology. And very soon we are looking for the new machine from Omron. Thank you.